acids, bases and salts, reaction of metallic oxides with acids. So we have to perform a small activity in a virtual way to understand this topic in a better manner. So the activity is something like this. Activity 2.7. Take a small amount of copper oxide in a beaker and add dilute hydrochloric acids slowly while stirring. So in general we know, right, copper oxide is black in color. We had learnt about this in the previous chapter, chemical reactions and equations, wherein we discussed that copper oxide is black in color. We have to take this copper oxide in a beaker and have to add dilute hydrochloric acid slowly while stirring. Note the color of the solution and what has happened to the copper oxide. So, in general, we have to note the solution. We have to note the color of the solution, right? Initially, copper oxide itself is in black color and dilute hydrochloric acid is just colorless, right? So, the solution might be adding black colored copper oxide in a colorless acid, okay? So, this is how the setup will be. And over here we are being asked to note the color of solution because over here there is a drastic color change you are going to observe, okay? And we are being asked what has happened to copper oxide. So I'll just give you a visualization of what will happen here. So we have copper oxide which is black in color, and when we add hydrochloric acid to copper oxide, what happens is a blue colored copper chloride solution is formed, okay? So let's understand this further. Copper does not react with HCl acid, but copper oxide does react. A metal acid reaction is always a redox reaction. We know, right? Copper do not react with hydrochloric acid. However, copper oxide does react, and this is a metal acid reaction, right? Because copper is itself a metal. So copper oxide is equally, or you can actually consider it as metal oxide, right? So you can say that metal or metal oxide and acid reaction is always a redox reaction. We will see further of how this reaction is a redox reaction. Metal oxides are mostly basic substances, and so they generally react with acids forming respective salts and water. Again, this is a big statement, okay? Metal oxides are mostly basic substances. Remember, always remember that metal oxides are basic in nature and non-metal oxides are acidic in nature. These 2 points are very important for you, at least in this chapter, and not just in this chapter. In fact, you will need it in all the further chapters as well. In fact, you will be learning about this in the chapter metals and non-metals, wherein you will get a clear idea of what metal oxides are, what non-metal oxides are, and why are these metal oxides called basic and why non-metal oxides are referred to as acidic substances. Okay, over here we know that metal oxides are basic substances, and because they are basic, they will generally react with acidic substances or acids to form respective salts and water. Copper oxide is a weak base and it is easily react with HCl or hydrochloric acid, forming soluble copper chloride and water. Okay, so over here copper oxide is a weak base, which means it is basic in nature. Hydrochloric acid, we have taken here dilute hydrochloric acid, right, which is again a acid for us. And what forms over here is soluble copper chloride. Now here copper chloride is a salt which is formed by the reaction of a weak base and a dilute acid, right? And along with the formation of soluble copper chloride, we also get a byproduct water. Now let's see the reaction. Here it is. CuO is copper oxide plus HCl is hydrochloric acid, forming CuCl2, which is copper chloride, and H2O, which is water. Now, as discussed in the first point itself, where we mentioned that a metal acid reaction is always a redox reaction. Now tell me, how can we actually tell it, or how can we define it as a redox reaction? See, copper oxide in the reactant side, copper oxide is like copper plus oxygen, right? So you can say that copper has oxygen with it in the reactant side. However, in the product side, copper is losing its oxygen, which means that copper is reduced. Similarly, in the reactant side, hydrochloric acid, you can see that hydrochloric acid is hydrogen plus chlorine, right? which means that hydrogen is having chlorine with it. However, in the product side, if you see, hydrogen instead of chlorine is bonded with oxygen, which means that hydrogen is gaining oxygen, right? So we know that when you lose oxygen, it means it's a reduction reaction, and when you gain oxygen, it means it is a oxidation reaction, right? So CuO or copper oxide is reduced to copper chloride and hydrochloric acid is oxidized to water. So that's how the redox reaction works over here. Okay, so that's all about this specific topic. I hope you understood it. Keep learning. Thank you.